atherosclerosis. We'll ignore the thrombogenesis index. Well, here's some common fats just to rank them by the atherogenic index. Coconut oil is a solid at room temperature, and it's, according to that equation, is very atherogenic. And the opposite in the scale, sunflower oil, 0.07. Polyunsaturated fatty acids, saturated fatty acids. And butter and other fats are in between. Typical Eskimo diet, 0.39. Typical Danish diet, 1.29, or British diet, 0.9. And I guess typical American diet is somewhere around 1, I would suspect, maybe around the British diet. Well, what's the atherogenic index of all of these fats from CLA-fed animals? Okay, beef loin, control animals, it was 0.82. CLA-fed, it increased a bit. So we didn't make an improvement. Now, that atherogenic index, though, does not take into account that CLA might be anti-atherogenic. That was CLA was not a part of the equation for calculating atherogenic index. But just looking at the fatty acids other than CLA, and according to Ulbrich and Southgate's equation, beef loin CLA feeding maybe made it a little more atherogenic because it decreased a bit the polyunsaturated acids. Pork loin, you see, went up. And that's what you'd expect when you see that belly. See, the bellies were stiffer, more saturated fatty acids. Eggs, look what eggs did. As I said, you could bounce a boiled yolk. It's significantly greater atherogenic index. Milk, that changed. It improved the atherogenic index of milk. And so this is another way of looking at products derived from CLA-fed animals. Okay, now let's look into the future just a bit. What should we at Iowa State be working on in the future? What should other people be emphasizing? What are they emphasizing? Well, this is a bunch of typos in this first sentence. But the first sentence is that one thing that really needs to be done is confirm all of the health benefits of CLA in well-designed, huge studies with humans and animal models. We need more studies with humans, especially on CLA's effect on atherosclerosis, on the immune function, and in fact on cancer as well. Number 2, develop procedures to increase the production of CLA or its precursor in the rumen and in tissues. If we could take advantage of those bacteria living in the rumen that produce CLA and force them to stop at CLA rather than reducing CLA all the way to stearic acid, then we could really improve the amount of CLA that a dairy cow puts in milk without feeding her CLA. Just feed her soybean oil and get even greater conversion of soybean oil to CLA. Develop technology to increase conversion of dietary CLA to animal foods. You know, when you feed CLA or any fat to an animal, they burn some of it to CO2. Well, if CLA is expensive, we don't want to burn that to CO2. We want it to end up in the meat, milk, and eggs. Number 4, confirm effects of dietary CLA on growth and meat quality traits. We need still more studies on the efficiency of growth when animals are fed CLA. And of course on composition of humans as well. Is it really anti-obesity in humans? Number 5, we need to develop a more economical source of CLA. It's been made by this Conlinco company, but they've been bought out by BASF. And BASF is claim that they have a technique that they believe is going to be cost-effective for farmers to buy CLA and then specialty market products from CLA-fed livestock. We'll see. And number 6, this is one that I think is very important, is understand the biochemical mechanisms of action of CLA in cells, organs, and whole animals. As you've probably summarized from what I've said, it seems that there's so many good aspects of CLA. What's the bad side? Well, one of the negative sides of feeding CLA to farm animals is it changes fatty acid composition a bit to seemingly make them more atherogenic than if they weren't fed CLA. That's the only thing that I've ever seen that's sort of negative related to CLA feeding. CLA consumption by humans seems to be something we should be thinking about seriously. Because epidemiological data suggests positive effects of CLA, and all the model studies seem to show anti-cancer, anti-atherosclerosis, improve the immune system, strengthen bones, improve glucose tolerance. It goes on and on. And it's really nifty. So what a neat molecule. Thank you very much for your kind attention.
Take a few questions.
Sure, absolutely.
Any questions?
What does it do to the taste of these meat milk and eggs?
Oh, we've done taste studies with beef, every one, pork, and nobody's ever been able to show any change in the taste. So, in fact, it seems that there's a study with beef that it might even decrease the radiation damage. When you radiate beef and some foods, you can detect a little bit of change because of radiation. CLA seems to protect against some of those changes even. So nobody's ever been able to detect the difference by sensory analysis.
Even when the egg yolk melts? It wouldn't be tasty.
That's it. Yeah, color and texture is changed in eggs, not taste, but texture and that's correct.
Don, what isomers have been shown to be the active ones?
Well, that's a very good question. The specific isomers, some of them there's enough of them available to do experiments with small animals. And so the only definitive answer to your question is that the 1012 isomer seems to be the anti-obesity isomer in mice. That experiment has been done. The specific purified isomers are not available in large enough amounts to feed to larger animals or to humans. So the prediction would be if the 1012 isomer is anti-obesity, if there is an anti-obesity effect. And see, this large human study was conducted with a mixture of isomers, 1012 and 911. And maybe the 1012 effect, if it is the same as in humans as it is in mice, maybe the effect was diluted out by the 911. I don't know. But the best evidence right now is the 1012 is anti-obesity. As far as the cancer effect, that's not been looked at and reported on yet. Doug?
Can you say a couple more words about oxidation? I always had a feeling that oxidation was very important in all of these acids.
You mean oxidation by burning the CO2 or oxidation making free radicals and all that? Well, that's very controversial about CLA. You can find about equal number of papers that say CLA is pro-oxidant, or you can find the same number of papers that says it's an antioxidant. So I don't know. There's when pork goes from if pork retains its nice pretty red color longer, it's thought, because of CLA, it's thought that it's be an antioxidant there. And what that means is that as pork goes from a pink color to a lighter color, it's myoglobin converting to metmyoglobin because of oxygen. And the theory is that CLA reacts with that oxygen rather than the oxygen reacting with the myoglobin and being an antioxidant and allowing color preservation. But that's that's in the print. But then on the other hand, it looks like the double bonds would be oxidized like in linoleic acid through the free radical formation and chain reaction, so to speak. So I tend to think that CLA is not an antioxidant, because if I open this CLA, it's very rancid. And I keep thinking of if a material is an antioxidant, should it itself go so rancid? I don't know. But this is very rancid, and you stick it on your fingers and you smell it for a day or so. Any other questions? Yes.
You mentioned with the eggs,
Uh-huh.
question the fertility of the eggs.
Yeah.
Has there ever been studies with checking any of these animals as their fat reduces to the fertility of the animals or not?
Yeah. Let's see. There's evidence in, I think it's Bob or Cook at Wisconsin did. See, a lot of this work originated out of Wisconsin. That's for sure. Cook showed that in chickens. Now the question is, humans. If humans consumed 1 gram, if a human female at the reproductive age consumed 1 gram of CLA per day, are they going to be as fertile as if they consumed the normal amount in food? I think that has to be thought about seriously. And I don't know of any experiment done with any animals other than birds, chickens right now. There's beef cattle. Are they less fertile when you feed them high amounts of CLA? I frankly think the effect would be greater in pigs because so much of the CLA you feed beef cattle gets converted to something else in the rumen. So the pigs, I think, would have a greater effect. And so I think you could easily test that in pigs, but it hasn't been done yet, to see if you can change fertility in pigs. Go from 10 pigs per litter to 6 pigs per litter. Well, that's not good.
Before we break up, I call your attention to a Sigma Psi lecture in February, the first Thursday in February, I believe it is. Dr. Lovell Jones of the MD Anderson Clinic in Houston will be talking about breast cancer. So we'll keep that in mind. There'll be announcements coming out on that. Let's thank Don one more time.